On March 3rd, 2026, the moon is going to bleed. And I don't mean that in some poetic, metaphorical way. I mean the actual moon, the one you can step outside and look at, is going to turn the color of a dying ember. Deep red. Almost rust. Like something is wrong. But here's the thing. Something is different about this one. This isn't just another lunar eclipse. We've had those before. What's happening on March 3rd, 2026 is a convergence of events so rare that astronomers have been circling this date for years. And once I walk you through exactly what's going on up there, I think you'll understand why. Because what you're about to see is not just a moon turning red. It's the third act of a cosmic sequence that only happens once in a generation. It involves a galaxy being swallowed by our moon, a cultural celebration shared by over 1 billion people, and a window that once it closes won't reopen for nearly 3 years. So let's talk about what's actually going to happen up there on March 3rd and why this one is unlike any blood moon in recent memory. What a blood moon actually is. First, let's make sure we understand what we're actually looking at, because the science behind this is genuinely stranger than most people realize. Most people have seen photos of blood moons. That deep red glow, almost like the moon is on fire from the inside. It looks dramatic, otherworldly. And for most of human history, people thought it was exactly that, a sign from the heavens that something terrible was coming. Wars were delayed over it. Empires interpreted a red moon as divine judgment. Columbus famously used a predicted lunar eclipse to frighten indigenous people in Jamaica into supplying his crew. He knew the eclipse was coming, and he used that knowledge as leverage. The mythology around blood moons is ancient, widespread, and deeply human. But the real explanation is somehow even more extraordinary than the mythology. Here's what's going on. The moon doesn't produce its own light. It's just a giant rock, and the light you see when you look at it is actually sunlight bouncing off its surface. So during a normal full moon, the sun is essentially using the moon as a giant reflector, a slow-turning mirror, shining a light back in your direction from 384,000 kilometers away. Now, a lunar eclipse happens when the Earth gets in the way. When our planet slides directly between the sun and the moon, it blocks that reflected light, and the moon falls into Earth's shadow. Simple enough. But here's where it gets interesting. The Earth casts 2 layers of shadow into space. The first is called the penumbra, a soft, fuzzy outer ring where only part of the sunlight is blocked. Think of it as partial shade. The second is called the umbra. That's the deep, dark core, the place where, if you were standing on the moon, looking back at Earth, the sun would be completely hidden behind our planet. Total darkness, in theory? Think of it like this. You're standing in a room, and someone steps in front of a lamp. At first, you might notice a slight dimming. The lamp is partially blocked. That's the penumbra. But if they move close enough to block the lamp completely, you fall into full shadow. That's the umbra. When the moon passes fully into the umbra, we call it a total lunar eclipse. But here's the thing. The moon doesn't go dark. Even though the sun is completely blocked, Light is still reaching the moon. It arrives from every single sunrise and every single sunset happening simultaneously on Earth at that exact moment. As sunlight grazes the edges of our planet, it bends through our atmosphere, and our atmosphere acts like a filter, absorbing the blue wavelengths and transmitting the red one. It's the same physics that makes sunsets red. The longer the light travels through atmosphere, the redder it gets. So what arrives on the lunar surface is a warm, reddish-orange wash, all of Earth's sunrises and sunsets happening at once, projected together onto the moon like a slow, planet-sized lantern. That's the blood moon. You're not watching the moon change. You're watching Earth's entire atmosphere glow red, projected 384,000 kilometers into space. Now, not every blood moon looks the same. The shade of red depends entirely on what's sitting in Earth's upper atmosphere at the time. Major volcanic eruptions pump enormous amounts of ash and sulfur dioxide into the stratosphere, and that dramatically darkens the eclipse. In 1963, after the eruption of Mount Agung in Bali, the blood moon that year was so dark that observers could barely find it with the naked eye, almost black, just a faint smear in the sky. Other years, with cleaner air, the moon glows a vivid copper orange, almost warm-looking. Scientists actually have a scale for this. It's called the Danjon scale, named after the French astronomer André-Louis Danjon, who developed it in the early 20th century. It runs from 0 to 4. 0 is an almost invisible eclipse, the moon barely darker than the surrounding sky. 4 is the brightest possible blood moon, a vivid orange-red with a bluish outer limb. Most eclipses fall somewhere in the middle. Where March 3rd lands on that scale depends entirely on atmospheric conditions at the time of totality, conditions no one can fully predict in advance. That uncertainty is part of what makes watching a lunar eclipse in real time irreplaceable. It's one of the last major astronomical events where you genuinely don't know exactly what you're going to see until you see it. This one could be a deep, almost maroon red. It could be a bright burnt orange. Nobody knows until it happens. But whatever color the moon turns on March 3rd, it's going to be doing something that no blood moon in recent memory has done at the same time. And it starts with a pattern that's been building for over a year. The tetrad, 3 blood moons in 1 year. In the long history of lunar astronomy, there's a phenomenon called a tetrad. It's a sequence of 4 consecutive total lunar eclipses, each separated by about 6 months, with no partial or penumbral interruptions. Just 4 full blood moons in a row. Tetrads are uncommon by any measure. Between 1600 and 1900, 3 full centuries, there were 0. Not one. The geometry simply didn't cooperate. And now, compressed into just over 12 months, we're watching one closeout. Here's the full sequence. March 14th, 2025, the first blood moon. A total lunar eclipse visible from Europe, Africa, and the Americas, the moon glowing deep copper above millions of cities at once. 6 months later, September 8th, 2025, a second total lunar eclipse, giving us 2 blood moons inside a single calendar year. Rare on its own. And then comes March 3, 2026. The third. 3 total lunar eclipses in 12 months. You'd have to go back to the mid-2000s to find a comparable run, and before that, the early 1980s. Entire generations of skywatchers never see a sequence like this. Technically, what we're inside right now is called an almost tetrad, because the fourth and final eclipse in this run, arriving on August 28, 2026, will be a partial eclipse rather than a total. The moon will enter Earth's shadow, but not completely. One side will darken, but the full blood-red transformation won't happen. It's the difference between watching a fire at full burn and watching the embers die down. Think of it like a symphony building across three movements. The strings build, the brass enters, the percussion joins, and then the final movement resolves quietly, almost gently. The spectacle is nearly over. March 3rd is the last full crescendo. So why do eclipses cluster like this? Why not one every couple of years, spread out evenly? The moon doesn't orbit Earth on a flat, level plane. It's tilted about 5 degrees off from the plane of Earth's own orbit around the sun. Most of the time, during a full moon, the moon passes slightly above or below Earth's shadow, close, but not quite in alignment. No eclipse. But twice a year, the moon's tilted orbit crosses the right plane at the right moment. Astronomers call these eclipse seasons. They last roughly 35 days and repeat about every 6 months. When the moon happens to be full during one of these windows, you get an eclipse. When multiple seasons align favorably across consecutive years, you get a tetrad. 2025 into 2026 has been one of the most eclipse-rich windows in recent memory, not just for lunar events. 2 total solar eclipses are happening in 2026 as well. An annular Ring of Fire eclipse already crossed Antarctica in February. And a total solar eclipse in August will trace a path across Europe and North Africa, the first to do so in nearly a decade. The geometry of the solar system has lined everything up in a narrow band of years, and we are living inside it right now. Most people have no idea. What's worth understanding here is that this kind of clustering isn't random luck. It's governed by a repeating astronomical cycle called the Saros cycle, a period of roughly 18 years and 11 days after which the Sun, Earth, and Moon return to nearly the same relative positions. Eclipse patterns repeat. They're predictable centuries in advance. Ancient Babylonian astronomers were tracking the Saros cycle over 2,500 years ago, using clay tablets and careful observation to anticipate when eclipses would occur. The fact that we can predict the March 3rd eclipse to the exact minute is a direct inheritance from that tradition. We are doing astronomy that has roots going back to the very dawn of recorded civilization. But the tetrad is only part of the story. Because something else is happening during this particular eclipse, something that excites even veteran astronomers who've seen blood moons their whole careers. And it has nothing to do with the color of the moon. The moon eats a galaxy. During the March 3rd eclipse, the moon is going to block a galaxy. Not figuratively. Literally. As the moon moves through Earth's shadow, its path through the sky will carry it directly in front of a distant spiral galaxy called NGC 3423. This galaxy sits roughly 25 million light-years away, so far that the light leaving it right now won't reach Earth until long after every human alive today is gone. And for a brief, specific window, the moon will slide directly in front of it, blocking it completely from view. Astronomers call this an occultation. Lunar occultations happen all the time. The moon regularly passes in front of stars, asteroids, and other objects. That part isn't unusual. What is unusual is witnessing the occultation of a deep sky object while the moon is in total eclipse. And the reason that combination is so rare comes down to a basic problem with light. On any normal full moon night, the sky around the moon is flooded with reflected brightness. Even seasoned astronomers with serious equipment can't observe faint objects close to the moon. It simply overpowers them. A galaxy sitting near the full moon in the sky? Invisible. Completely washed out. But when the moon enters totality, something remarkable happens. That brilliant white disk drops to a dim, reddish glow. The sky immediately around it darkens. Stars that were invisible just minutes before start emerging. Constellations reappear. And objects that would never be visible on any other full moon night, faint nebulae, distant star clusters, and yes, galaxies, suddenly come within range. So here's the specific moment to watch for. During the heart of totality on March 3rd, observers across North America will be able to watch the blood moon move directly in front of NGC 3423. The moon will swallow it. And then, as it continues along its arc, the galaxy will reappear on the other side, like a ship emerging from behind a lighthouse. In the span of a single hour, the moon will hide and then reveal a spiral galaxy located 25 million light-years from Earth. This kind of event, a galaxy occultation observable during full totality, is rare enough that it gets documented in dedicated astronomical papers. And yet you don't need a research-grade telescope to see it. A pair of binoculars or a small consumer telescope pointed at the right place during the right window is all it takes. The moon will be in the constellation Leo during this eclipse, sitting just under the lion's hind paws, according to NASA's own visualization. Leo is a relatively open, uncrowded region of sky in early March with few bright foreground stars to interfere with the view. That's ideal for trying to spot something as faint as a spiral galaxy emerging from behind a blood-red moon. For the best view, look during the deepest part of totality, when the moon is at maximum eclipse and the sky around it is at its darkest. For viewers in Western North America, the geometry lines up best. The moon will be at a reasonable altitude, the sky will be dark enough, and the window will be wide enough to actually catch the moment. Astronomers have been flagging this occultation specifically, not as a footnote to the eclipse, but as a co-equal event. Two extraordinary things happening at the exact same time in the exact same patch of sky. It doesn't happen like this often. But there's a third storyline to this eclipse, and it's the most human one. 1 billion people, one blood moon. March 3rd, 2026 is the last night of the Lunar New Year. Most people in the West think of the Lunar New Year as a single-night event. It isn't. In Chinese tradition, the celebration runs 15 days, each with its own customs, rituals, and foods. And on the 15th and final night, when the first full moon of the new year hangs in the sky, families gather outside for the Lantern Festival. They carry glowing paper lanterns. They eat sweet, glutinous rice balls called tangyuan. and they look up at the moon together. This tradition has continued, unbroken, for more than 2,000 years. This year, that moon is going to turn red while they're watching it. Think about what that is actually going to look like on the ground. In China, South Korea, Japan, Vietnam, Taiwan, and in Chinese communities across every continent, hundreds of millions of people will already be outside. The streets will be lit with lanterns. Families will be gathered. People will already be pointing at the moon, already paying more attention to the sky on this night than on almost any other. And then it starts to change color. For those of us who understand science, it's a breathtaking coincidence. But the Lantern Festival has always been a moon-centered event, and a moon that bleeds red on its most observed night carries a different kind of weight. Some will read it as auspicious, a dramatic, powerful opening to the year ahead. Others will find it unsettling in the way any sudden change in a familiar sky tends to feel. The interpretations will vary across communities, generations, and belief systems. But everyone will be looking. And that convergence, a mass cultural gathering already oriented toward the sky, on the exact night the sky does something it hasn't done on this occasion since 2017, is something that cannot be manufactured or repeated on demand. The last total lunar eclipse to fall on the Lantern Festival was February 11th, 2017. The one before that was decades earlier. These overlaps are genuinely generational. And the connection between lunar eclipses and human understanding runs even deeper than celebration. It runs through the history of science itself. Aristotle, observing a lunar eclipse from Greece roughly 2,350 years ago, noticed something about Earth's shadow. It was always curved. No matter the angle of the eclipse, the shadow Earth cast on the moon was consistently circular. And there's only one shape that casts a circular shadow from every direction, a sphere. That observation reached without satellites, without modern instruments, without anything beyond human eyes and careful attention, was one of the first rigorous scientific arguments that Earth is round. A blood moon told us the shape of our own world. Long before anyone had the tools to leave the planet, long before space travel was even a concept, people used a lunar eclipse to figure out the fundamental geometry of the rock they were standing on. That's extraordinary. And we have been using lunar eclipses as tools for understanding the cosmos ever since. Now let's talk about who can actually see the March 3rd eclipse, because not everyone gets to be part of this, and that scarcity matters. Europe and Africa are out completely. If you're in London, Paris, Lagos, or Cairo, the geometry doesn't allow it. The moon will have set before totality begins, or won't be high enough in the sky by the time the eclipse peaks. There is no workaround. For those regions, a live stream is the best option. North American viewers are in, but timing varies by location. The eclipse unfolds in the pre-dawn hours of March 3rd. Western North America gets the clearest, most complete view. Moving east, the moon sits progressively lower near the horizon as totality begins. East Coast viewers will need to be awake before 6 in the morning with an unobstructed western horizon, and even then, the moon will be low. Worth it, but it requires planning. Eastern Asia and Australia have the premium seats. The eclipse unfolds in the evening sky, well-positioned, accessible, no pre-dawn alarm required. For viewers in Japan, South Korea, China, and Australia, this is among the most conveniently timed total lunar eclipses in recent years. The point is simple. If the geometry works for you on March 3rd, there is no good reason to stay inside. Then it's gone for 3 years. Here's the part people tend to underestimate until the window closes. After March 3rd, the next total lunar eclipse, the next true blood moon, won't happen until December 31st, 2028. New Year's Eve, 2028. Nearly 3 years away. And the one after that pushes into 2029. The tetrad is ending. The eclipse-rich window that's given us 3 blood moons in 12 months is closing. What follows is a long, quiet stretch where the moon and Earth and sun simply don't line up the right way. 3 years is a meaningful gap in human terms. If you're watching this with children who have never seen a blood moon, March 3rd may be the last accessible shot before they're teenagers. If you're an astrophotographer planning a long exposure image of a red moon, the door is open right now. In 3 years, it won't be. There's also something worth appreciating about lunar eclipses that separates them from every other major astronomical event. Unlike a total solar eclipse, which carves a narrow corridor a few hundred kilometers wide across Earth's surface and leaves everyone outside that path with nothing, a total lunar eclipse is visible from an entire hemisphere at once. Half the planet watches the same event simultaneously. No travel required. No eclipse glasses. No hotel booked 18 months in advance. Just a clear sky and the willingness to be awake. Lunar eclipses are the most democratic astronomical event we have. The same sky shared by billions of people at the same moment. Totality on March 3rd runs for 59 minutes of full blood moon. The deepest red, when the color is most saturated and dramatic, hits at maximum eclipse. That's a generous window. Some total lunar eclipses offer only a few minutes of totality, the moon skimming the very edge of the umbra and slipping out quickly. Others, perfectly centered through the shadow's core, push close to 2 hours. March 3rd lands solidly in between, long enough to absorb, long enough to photograph multiple exposures, long enough for the kids to drag blankets outside and actually remember it. And inside that totality window, the galaxy occultation is happening. While the moon glows copper red and the sky around it darkens that narrow slice of night when stars reappear beside a blood-colored moon, it will simultaneously slide in front of NGC 3423, a spiral galaxy 25 million light-years away. The blood moon and the hidden galaxy sharing the same hour. The closing act of the tetrad. The lantern festival lighting up the eastern sky. The long quiet that follows. All of it converges inside a single 59-minute window on March 3rd. If the universe is trying to get your attention, this is how it does it. So mark the date. Set the alarm. If you're in North America, look west in the hours before dawn. If you're in Asia or Australia, step outside after dark. And if you have any kind of optics, binoculars, a small telescope, a camera with a zoom lens, point them at the moon during totality and search for a galaxy appearing on the far side. You probably won't get another chance like this for a long time. And if this eclipse has you wondering what else is happening out there, what other events, anomalies, and unsolved mysteries has deep space right now, hiding in plain sight, then like and subscribe for more. Because we've barely scratched the surface of what 2026 has in store. The sky isn't done with us yet. I'll see you in the next one.